Okay, folks, here we go. 2 additional practice. This is page
27.
27 and 28 in your packet. Here we go. Solving equations, variables on both sides. So let's get at it. Folks, I got rid of the boxes here. Okay, step number 1. We have to combine like terms, but in this case, we have terms on both sides of the equal sign. This is where we have to use inverse operations. And as Mr. Fricky taught us in the lesson, start with the smaller of the two coefficients and get rid of it. Okay? So I find my coefficient, 6.4, 4.4. Hey, I'm going to get rid of that by using inverse operations. So I'm going to take away 4.4n from both sides.
Yeah.
That leaves me with 2n over here minus 10 equal to 6. Next step, get rid of the constant term that is alongside the coefficient term. So, in order to get rid of a minus 10, again, inverse operations, we're going to add 10 to both sides. That's going to leave me with 2n equal to 16. Once again, hey, here's a variable term held together by multiplication. Split it by using division. Take 16 divided by 2. Folks, you're going to end up with 8. Okay? Jumping over here to number 2. Identify your variable terms. Which one's the smaller of the two? Hey, 1/3 is less than 1/2.
That's right,
so
people.
I want to subtract the 1/3 k from both sides. That's going to leave me with only 80 on this side. 1/2 minus 1/3. Well,
1/6. 1/6.
Hey, there you go. It's 1/6.
I heard it from somebody.
Plus 120. Once again, variable term along with the constant term. Hey, we got to get those away from each other.
Yeah.
Isolate the variable term, which means get rid of the constant term from that side. Inverse operations, opposite of adding 120, subtract 120. Bingo, here we go. Now we're left with 1/6k equal to a negative 40. Hey, last step is, again, break this variable term apart using inverse operations. Divide by 1/6, divide by 1/6. And folks, I can do this one in my brain. K is equal to a negative 240.
Ding, 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 ding.
Okay. Here we go, moving on down. Number 3, you and a friend are doing math homework together. You have to solve this equation. Your friend arrives at this. Is she correct? Probably not,
Or they wouldn't be asking this question.
but let's check and see. 5x plus 4x minus 68 equals 34 minus 8x. Here we go. Oh, wait a second. 2 like terms on the same side. Let's start by combining those.
It's just what we did in 2-1, guys. Now it looks like what we're doing right now.
That's right. Okay, find your smaller of the two. 9x, negative 8x. Negative 8,
Negative 8's the
smaller.
smaller one,
So
yeah.
I'm going to add. I'm going to do the opposite. So I add to both sides. This is gone. Now I got 34. Ooh, this is 17x
Man,
minus
good work.
68. Next step, variable term, constant term. They're together. They shouldn't be. Get rid of the one by adding the constant term to the other side. So now, boom, this is 17x. Over here is 112. No,
102. 102.
102, my friends. Last step, we got 17x equal to 102. Sorry about the tough part of seeing here. Divide by 17. 102 divided by 17. X equals 6, my friends. Is she correct?
No.
Explain. See. Work.
Guys, sometimes you can explain with your work. You don't have to explain in words.
See. Work. Okay? She's not right. Moving on. Number 4. Is that big enough for you guys?
There
How
it
about
is.
that?
That's better now.
Okay. Boom. Variable term on both sides.
Bring them together.
Start with the one that is smaller and get rid of it. Well, 3/8 is smaller than 5/8. Let's take it away. So I take it away. That means I'm left with 2/8 over here. Now I'm going to perform magic. 2/8 is equivalent to 1/4.
Woo! That was magical.
Next step, variable term, constant term. Get rid of the constant term. Now, in this case, I'm not going to add 4 to both sides because I got to do the inverse or opposite of adding 4, which is subtracting 4. That leaves me with 1/4 x over here and an 8 over here. I know it's hard to see. I'm going to put it over here. 1/4 x equals 8. Last step, break this apart using division. Divide by the coefficient.
Divide by 1/4 on both sides, folks. Here we go. K equals X equals 32.
32. Boom. Moving on.
Combine like terms here, people.
Give us more room to do more work. Okay? Combine like terms. Starting it off. Those two terms combine together to be a negative 3x.
Move the smaller variable term.
Negative 3 or positive 2? Which one's smaller?
The
Negative 3
okay,
is.
yep.
So we got to do the opposite of it, so we're going to add 3x to both sides. 150 here, 120. Well, 2x plus 3x, combine like terms, that gives you 5x. Next step, here's my variable term with the constant. Got to get rid of it.
Gotta go.
Opposite of it, we subtract 120. Okay, that will leave me, and I'm going to write it down here. 5x equal to, well, 150 minus 120 is, whoa.
Whoa, that's the ugliest 3 I've ever seen, folks.
30. Last step, divide by that coefficient. So we divide by 5, and folks, x is equal to
6.
6.
We just had a 6 earlier, too.
Man, this is awesome.
Love it.
But notice, most of the time when we're solving these, your values are going to come out to be whole numbers or a terminating decimal. If we get some crazy looking number,
Yeah.
check your work. It's
Yep.
probably wrong. Okay, number 6. Oh no, now we got
The dreaded word
The
problems.
dreaded word problems.
Guys,
Around-
as you read through, think about which is my constant term and which is my variable term.
They charge $240 per week plus 25 cents every mile to rent a car.
Okay.
They charge for a minivan, what Mr. Frick and his family would
Yeah.
rent. Okay, he looks sweet driving a minivan.
It's a sweet
Now
minivan.
the phone's ringing. Just
The
be
phone.
patient. We got $180 per week plus 40 cents a mile. How many miles will they be the same?
Mr. Ma, you want me to answer it or decline it?
Well, maybe you should take the power of the pen. I don't know. Folks, this is where tough times call for tough decisions we got to make. We're
Tag team.
we're
He's
throwing
coming in.
a substitute
Bam!
in here. He's
How's it
in.
going,
Let me
folks?
go get the call.
Great to see you. Okay. We gotta write 2 equations again. It says after how many miles is the total charge for each vehicle the same? The same, right? So are they equal to each other? Okay? Alright. So we're gonna take rental car charges $240 a week and 25 cents a mile. Right? One of those is always the same. One of those numbers is changing. Right? $240 a week, always the same. Right? 25 cents a mile. Right? Again, we add those two amounts together. That's how much I'm spending to rent this car. When I get my sweet minivan, all right, it's gonna take that same structure. All right. So we get charged $180 a week plus 40 cents a mile. Okay. So $180 a week, 40 cents a mile. So here we are right here. 40 cents times however many miles we drive. We have to add that $180 charge to it. Now we're good to go. Okay? Solve this equation. Right? We're going to move our smaller 0.25 variable term over here. Okay? We're just going to subtract 0.25. Subtract 0.25m. Goes away here. 240 equals 0.15m plus 180. Okay? Move that 180 over, so we're going to subtract it. Run into the same problem Mr. Noel had. I ain't got no more room. This should turn into 60 equals 0.15m. Right? Are we done here? It says m equals, right? Yeah, we got to be solved for 1. So divide by your coefficient. Again, dividing by a number smaller than 1, guys, we should get an answer that's bigger than this. Any
Fold.
guesses?
I know it.
Mr. Knoll knows it. What do you got, Mr. Knoll?
400.
That's right, 400. So that means if we drive 400 miles, our charge for both of these vehicles is the same.
That's why they're equal.
They're equal. Okay.
You want me to jump back in?
I don't care. You guys want Mr. Knoll to come back in here? All right, they said yes.
Oh, doggone it.
Good choice, people.
Okay, looks like same type of question here. Smith family and the Jackson family are having their basements remodeled.
Yes.
The Smith's contractor charges $16.50 per hour. Please get me in touch with this contractor. They
Yeah.
charge $16.50 an hour plus $289 in supply. Sounds like this is a variable term. This is going to be a coefficient or a constant term. Jackson's contractors, $18.75 per hour and $274.60.
Man, very accurate there.
Yeah, I like it. At how many hours will the cost be the same? Meaning equal. So let's talk it up. $16.50 per hour. Well, that's a variable term.
Yep.
The number of hours can change, folks. That's not always going to be the same.
Not always the
so
same.
It's always going to be multiplied by the number of hours. Plus the $289, which will be constant, that will never change. They're going to charge $289 for supplies. This, we want to know, when is it the same as variable term, 18.75x, and their supplies, which is $274.60. We got to solve.
Yay.
Okay, take away the smaller of the two coefficients. I'm going to subtract $16.50 from both sides. That leaves me with $289 here. Oh, looks like 2 1/4 here. Plus the $274.60. $274.60. Next step, variable term along with the constant. Once again, we got to get rid of it. So I take away the constant. We're left with $2.25 times x. That looks like about $14.40 over here. Last step, break it apart by dividing. And $14.40 divided by $2.25. We are looking at probably about 6.5, 7.4. 7.4.
6.
6.
You were right the first time.
Doggone it. 6.4 hours, my friends. 6.4
Beautiful.
hours. Okay. Moving on. Turn the page. Flip it over. We got Jim. He's got a bank account. Way to go, Jim. He's got $1,250 in his account. Sally, she got more. She got $1,400.
It's good to be Sally.
Jim puts in 27. Now I said puts in or deposits $27.50 per week, and Sally deposits $20 per week. After how many weeks will they have the same? Oh man, it sounds like we're going to be setting two things to be equal. Well, let's say Jim over here. We want to know, when does Jim equal Sally?
Yep.
Well, Jim, he's got $1,250 plus he deposits, there's Jim, $27.50 every week. Okay, that's our amount that can change depending on the number of weeks. Sally, she's got $1,400 plus she puts in $20 per week.
Good for her.
Good job, Sally.
Way to go. Good job.
Okay, find your smaller of the two coefficients.
20x.
Get rid of it. Whoa, we subtracted. Take it away from its like term over here. That will leave me with $1,250 equal to plus $7.50
be careful.
times x. This is gone. We only have $1,400 here. Next step, subtract. Get rid of this constant term that is on the same side as the variable term. I subtract. That's going to leave me with just the variable term here equal to $150 here. Last step, divide by the coefficient. So we divide by $7.50. And your number of weeks that they will be the same is the big 20. Okay?
That's right.
That's the big 20. So once again, what that means, if they're both saving for 20 weeks, at 20 weeks, Jim will equal Sally.
Yep. Good stuff. Mr. No, let's skip number 9. Let's get right to 10, shall we?
That sounds like a great idea. Hey, ooh, I like this one. Step 1, combine like terms over there. Why did I know to combine those like terms? Because they're on the same side and they have the same variable. So we just add it, subtract it. You know, whatever it says to do,
Yeah.
do it. So in this case, we add it. That's going to be 8 over 3x. Now, some of you may look at this and go, that's not what my calculator said. Well, then change it
2 2/3.
to 2 2/3. I don't care. It's the same value. Okay? Mixed number. Other one, improper fraction. Whoa. Where did
Ooh,
yellow
I like
come
the
from?
yellow. That's nice.
Where did the yellow come from? Anyways, hey, variable term on this side, constant and variable term. We've always said get rid of the variable term that is with the constant. So let's get rid of it by doing the opposite. That's great. Now if I subtract that, that's going to give me 3/3,
Uh-oh.
right?
What's a better number for 3/3, people?
Equal to 1. Wow, 3/3. That's just 1. Well, doggone it, I'm done. 1x equals 1.
Beautiful.
Man, that wasn't so bad.
Nope.
All right. Moving on down. Ooh, this is lovely. School A and B are competing in an academic
Dun,
contest.
dun, dun, dun.
At the beginning of the final round, School A has 174 points and School B has 102.
Oh, man.
School B must stink. They're getting smoked.
Yeah.
In the final round, correct answers earn 10 points. Incorrect answers lose 6. If you lose points, I wonder if that's going to be adding or subtracting.
Lock in your guesses.
I think it's going to mean if you're losing 6, that's got to
Yeah.
be you're taking 6
Going
points.
down.
School A gives the same number of correct and incorrect answers during the final round. School B gives no incorrect answers. Wow. And the same number of correct answers as School A. The contest ends with the two schools tied.
Oh, my goodness.
It's like kissing your sister. Part A. Which equation models the scoring in the final round and the outcome contest? Well, it's the School A. They started with how many?
174.
They got some questions right, and they missed some questions. So they got 10 points per question, but then they also lost 6 points per question.
Yep.
So with the 174, I need something to show adding 10 points each and subtracting 6 points each. With the ones, nope.
Nope.
It's not that one, is it?
I don't think it's A.
No, because this one's only showing that they got answers right. It's
Yeah.
not showing anything where they missed.
No.
It's showing the other team missing points.
Yep.
No.
I think we can get rid of one more, people.
Yeah. By all means, we can get rid of that one.
Yep.
Because they got some questions right. It's not showing it.
Okay.
Oh, boy. Well, it looks like we're going to have to look at School B because the first part of this
Are
same.
identical.
So let's look at School B. School B gave no incorrect answers and the same number of correct answers as School A. Well, you get 10 points for each correct answer. So would they add 4 points per question or add 10 points per question?
Ooh. Yes. Yes.
Right
Good
on.
job.
Oh, I bet you on part B we get to figure out how many
Yes.
questions they actually
I
answered.
wanted to solve this equation.
How many correct answers does each school give during the final round? Well,
Okay.
folks, we got to take.
Got to take that equation.
Now, I'm going to just over here save some room over there. Let's combine these two terms. 10x minus 6x.
Combine like terms, guys.
That's going to give you 4x equal to 102 plus 10x.
Okay, move the smaller variable term.
Okay, now am I going to add 4x to both sides?
Well, yeah, it says plus 4x,
No,
right?
you do the opposite.
Whoa!
Do the opposite. That leaves us with 174 over here. 102 plus 6x. 10 minus 4 is 6.
Got it.
Hey, variable term, constant term, get rid of it. get rid of that constant term. That's a 102 gone. 6x. This is 72 over here. Last step, divide by the coefficient. I bet you, Mr. Fricky, the number of correct answers is 66. I took 72 minus 6.
Yep.
No.
No.
Nope.
Oh, that's what I had.
You need to take 72 divided by 6.
Oh,
Which
it's 12.
is 12. Okay, so folks, there's 2 additional practice. You're going to move on, do the 2 Math Excel, and do the work in the book, which is probably about pages 95 and 96. Hopefully this helped. See ya.